Okay, hi everybody around the world, and thank you for joining our third presentation of our webinar series, Hoppy Topics. My name is Sandro, and I'm working for the technical support at Hopsteiner, Germany. Today we have a very interesting presentation about the usage of hop oils, but before we start, I'd like to give a very short introduction, especially for all new participants around the world. Our webinar series is a free online seminar with presentations about hop-related topics. As we are still facing the limitations of the COVID-19 regarding traveling and meeting each other, we have decided to additionally offer this kind of online support for you. Like this, we want to keep you up to date about the latest research in hops, new product developments, and the many more insights of the hops' versatile contribution in beer production. Before we start, I'd like to say that your questions are highly welcome. You can address them on the right side of your screen through the Q&A tab. Your microphone and your camera remain switched off during the whole webinar, but you can address your questions to me and I'll pick it up at the end of the presentation. The presentation itself will take about 45 minutes, followed by the Q&A session, so in total we have about 1 hour. Here with us today, we have Frank Peifer, our technical director at Hopsteiner. Frank started his brewing career 35 years ago after receiving his degree as an engineer in brewing science and beverage technology. Prior to his career at Hopsteiner, he worked at the Bavarian Staatsbrauerei Weinstefan as director of operations. Frank joined the Hopsteiner German team as technical director in 2015. He provides technical support for many breweries and brewing groups around the world. He supports R&D activities for new product developments and technical applications. Besides, he's also responsible for the processing and packaging plants and our technical advisor for optimizing our processes and technologies. Frank, I hope I mentioned everything what you do, and now I give the words to you.
Yes, Sandro, thank you very much for your kind introduction. Yes, good morning and hello everybody around. So my today's presentation will be about the application of hop oils in beer production, and at the beginning we will see a little bit and we'll learn a little bit about certain hop aroma compounds, how they behave, and then we go later on into more details regarding application of hop oils and differences between our products that we have on the market, which kind of beer you can use this or that hop oil product in your facility. So to start with the introduction, go to the topic, to the hops. You see here that is what you all know, that is a hop cone from inside. I think that looks like a magnum, because magnum is very typical that the lupulin comes out before harvest here on the top of the cone. And here we see in the middle, these are the lupulin glands, yellow particles, and the bracts and the bracteoles, the leaf material outside to cover, as also to cover the lupulin glands. These are picture from lupulin glands. They are sticking here on the internal area of the bracteoles of the hop cone. These small yellow bubbles, they contain the resins, the bitter compounds, and they also contain the hop aroma compounds, the hop oils. They are covered with a very fine skin that keeps them safe away from the atmosphere. And what we need in the brewery is to find a way to bring these compounds from the glands into our beers. So today we are not talking about the leaves, the green material that contains more or less relevant particles like polyphenols, relevant for beer production. And we do not talk about the resins or the bitter compounds, if they are soft or hard resins. They're not relevant today, but today the hop oils are relevant. And let's go and have a look. What is the composition of the hop oils we find in worldwide hops? So that is a short overview with some examples that shows the main groups of aroma compounds. Here we have the examples in different colors, and that is the importance. So it's just, let me say, it's not a whole range of compounds that we have, but it gives you a good impression about the certain groups and how they behave. Before I want to say something more about the certain groups, you have to notice that nearly all flavors we have in the nature, in the world, can be described by these groups of aroma compounds. In different concentrations, in different types of molecules, but all these fruitiness, these flower effects can be described with these compounds. The red ones here, we start with the monoterpenes and the sesquiterpenes. Especially the monoterpenes, we know the myrcene, that is the highest group in our hop oil composition. It can be between 30 and 70% of the hop oil in total. And what we know about these compounds, they are very high volatile. So that means they are non-polar, and whatever they can do is to yes, they want to get rid of the product. They want to get rid of the beer, and if they find a way to leave the beer, they will do it. So the transfer of myrcene, especially in the brew house, even in late addition, that will lead into high losses. But when we go to dry hopping, then we can transfer a lot of them by this technology into the beer. The sesquiterpenes are often a key indicator for certain varieties. A composition and ratio of these compounds is very typical for a lot of different hop varieties. But in the real life, in brewing, it's hard to achieve, let me say, a reasonable concentration in beer because the threshold of these compounds, especially for caryophyllene and for humulene, is very high. And to find, let me say, a noticeable impression coming from these compounds is only achievable in dry hopping with very high hop additions. They are also volatile, but not that volatile than the monoterpenes here on top. Very important group are the monoterpene oxides. Here we have alcoholic forms that we talk about linalool, geraniol, citronellol, and terpineol, and they are lower volatile. They are polar, and that means if they are once added or adjusted in a beer or a wort, then you find a lot of them later on in the final product. So they have a high importance, very high importance, and also we know additive effects of these four compounds, and you find them in beers produced with hop additions in late hopping, that means in kettle or in the whirlpool, and also in dry hopping. Then we have some aldehydes and ketones. Some of them are more volatile than the other, but we find some of these compounds in beer, especially in dry hop beers, and they have a, let me say, a fruity or flowery-like notes, and even on very low concentrations, because they have a very low threshold, they have an impact on the hop flavor in this kind of beers. Coming next to the other active thiols, or called mercaptanes. There before we were talking about concentrations in microgram per liter, and now we go lower concentrations with nanogram per liter. That means when they appear in very low concentration, the nanogram levels, they have an impact on the flavor and on the taste of our beers, especially in dry hop beers, because they are also very volatile, and by additions into the kettle or into the whirlpool, they are more or less will disappear by evaporation. But we think that these compounds will also have a kind of precursor where they are bound to a sugar molecule, for example, and maybe there's also a release of these compounds later on in production. We all know these varieties like Nelson Sauvin and Cascade. Here we have the 3 MMP that gives a white wine-like note coming from Nelson Sauvin, and here for the 4 MMP that is very high present in Cascade, that goes into direction of black currant. But if you overdose, if you have higher concentrations of this compound, especially here in a beverage, it goes into direction of a cat piss aroma, and that is very negative. Next group, also very important, are the carboxylic acid esters. They are also not that volatile, so we find some of them coming from a late hopping addition, and also they are very highly present in dry hop addition, and most of them have a fruity character, and we know there are also synergetic effects from this aroma compounds together, let me say, for example, with monoterpene oxides or with the aldehydes and the ketones. So I want to talk a little bit about linalool, because linalool is very important, but we use linalool as a key indicator for hop aroma intensity, and that is only valid for, let me say, late hop beers. For beers hopped at a addition in the whirlpool or addition in the kettle at the end of the boil before knockout. They are not so much like an indicator for dry hop beers. But talk about late hop beers, we know that they provide a very pleasant aroma, and the determination of linalool is very easy to achieve in a laboratory. And if you find linalool, you will also find, if you go deeper inside, you will also find some geraniol, terpineol, citronellol as well. And they all together, they contribute to this typical flavor. Linalool also has a very good masking effect against beer aging. And that was determined by a colleague of us, by Professor Martin Grottenthaler in Weinstefan. And some years ago, he made a test with his students, and he had a beer that was, let me say, aged well, with a low acceptance by the students. And then he decided to increase the concentration of linalool in this beer step by step. And what he found was, with increasing linalool concentration, especially here the next step to 36 microgram per liter, the acceptance was going up. And here at 67, we had now acceptance of 90% and not anymore acceptance of 58%. And so that is a good information about how linalool works. Let me say it's covering this aging compounds a little bit, not in total, but it also has a limit. We see here when the dosage is going up over 100 microgram per liter or much more, it's also possible. The effect is not doing 100% at the end. So my recommendation is for, let me say, light lager beer, this 60, 70 microgram per liter. Also 50 can be enough for this kind of beers. If we have a stronger one, let me say a bock beer, then we can go over 100 microgram per liter with this positive effect. And maybe you find also this positive effect later on when your beer is in supermarket on the shelf. So let me say the perceived taste and flavor is a little bit better than without a good reasonable concentration of linalool. What we also have to know as brewers is that the concentration of linalool differs from crop year to crop year and is not constant in between the varieties. So I collected some data here from crop 12 to crop 19. Let's have a look on how they behave. Here we have the Saphir variety from Hallertau, and we see fluctuation is very high, especially here from 12 to 13, and also here from 15 to 16. And that is something that you have to know, because if you want to achieve certain constant concentration of linalool in your beer, you have to adjust your dosage when you turn from one crop year to the next. That is how Perle behaves. Perle is not, let me say, a linalool donator. Linalool is very low present in Perle, so it makes more or less no sense to use Perle as a late hop addition to achieve this hoppiness on this kind of beers. That is the tradition. It's also with a very good and strong fluctuation, and that is a middle free, looks the same. And that is Taurus, and we have to know Taurus is a bitter variety, but Taurus has a very high linalool concentration, and We also see the gap here in 18. There was a bad crop with a drought, and that has an impact on certain varieties, but not on all varieties. But here, especially for Taurus, it was. But Taurus is more and or less coming out of style, is replaced by Hercules, and the acreage of Taurus is going to be down to some hundreds now, and it's hard to get a bigger amount of Taurus. But I think it's a bit of hops at the end of the day, and it's not the right one to use Taurus here for late hop addition. It's just an example how hop varieties behave over the time. So that is a slide where we have a listed concentrations of linalool that we find here in Hallertau varieties. As I mentioned before, Perle is naturally very low. Then we have the today's bitter varieties, that is number 1 is Hercules, and here on second position that is Magnum, but they don't come up to the same concentrations than we find in the variety Taurus. Then we have Opal with also very high concentrations. Callista is also something that can reach levels over 10 milligram per 100 gram raw hops. And here the Comet is a new Hallertau variety that can go up to 13 milligrams. So that's a lot. And these varieties here, they are also handable and usable for late hopping to create such a late hopping like character on your beer. That comes from the US. We know the Centennial with a high linalool concentration, and especially the Eureka and Sultana that we have. It's private varieties from our company, from Hopsteiner. They show values in between 17 and 18 milligram per 100 gram raw hops, but they are also bitter varieties. In Slovenia, some of these hops can go up to 20 milligram per 100 gram, but the fluctuation, yes, let me say, forced by climatical conditions and weather, are very, very high. So can be in between 8 and 20. It's not stable, and so yeah, it's hard to achieve, and it's hard to calculate with these high differences you find there in between the different crops on these Slovenian varieties. What we also have to know is the ratio between linalool and the concentration of alpha acids or per alpha acid, because when this differs, we have to adjust. We have to find back our linalool value in this late hop beers, and that goes together, sometimes goes together with an impact of more or less alpha acids as an addition to knockout or into the whirlpool. That means when I have to add more alpha acids to achieve the same stable level of linalool in my beer, I have to reduce other hop additions, maybe the first addition at the beginning of the boil, to stabilize also my bitter units in the beer at the end. When we see here, that is the same effect I described before for the total concentration of linalool. We see here that the ratio is also going up and down, especially here for the middle free, for the Hallertau crop 18 and then up to crop 19. That is more than double, and that is something that you have to know and have to you have to put it into your balance of your hop recipe for your certain beers. And here Taurus is now on the lower level because of its high alpha concentration that can goes up to 16.5 and 17%. Maybe you heard about this word, that is a biotransformation, where especially the terpene alcohols are involved. That is something that was proven years ago by a brewing colleague from Japan, Takoi, and he found out that there be something that must going on, starting with geraniol coming from hops, and this geraniol goes into direction of citronellol or over linalool to terpineol. And he was able to show us that this really happens in life by measuring these compounds in different stages of beer production. So what we know today is that we have depending on the variety, we have a, let me say, a pool of geraniol and also a pool of geraniol precursors. And depending on varieties, we have here, for example, Bravo, Lotus, Sultana, comes from our house, but they are on a very high concentration on one side on geraniol or on the other side on geraniol precursors. So what happens with the geraniol precursors? We know that at the beginning of fermentation, our yeast is able to release enzymes, and this enzyme class that helps to split off the geraniol molecule from, let me say, a sugar molecule or from an aldehyde is the enzyme class of the beta glucosidase. And that is hard to find in nature, and this enzyme is normally only produced by microorganisms. So this enzyme helps to split off the precursor, and now we have more free geraniol that can go into this interaction, into this biotransformation, and in total we increase the whole amount of terpene alcohols by using the enzymatical power of the yeast. And it starts directly with fermentation when the yeast is able to release this enzyme. And we know there's always a coexistence of linalool, geraniol, and citronellol, and also from terpineol here as the final product. And we also found that this is still going on after the beer is on the shelf. Maybe it's something that is also enzymatically driven, or it depends on the pH of the beer. That is a question that we still have and where we need a little bit more insight in the future. So to go to the brewing process where we can add hops, that's not new for us, not new for you and me. We can make it in the kettle, we can make it at the end of the boil, we can make it also in the whirlpool. There's a second point or addition point for late addition. And we have another point as well, something that was forgotten in the last years. That is an application they called hopback. And that's not new. I think in the UK, there are a lot of brewers that do it for the cask beers. And that is in between the whirlpool and the cooler, where we are able to make an extraction of the hop aroma compounds with the hot wort that is flowing through this device, and everything happens under hot conditions. So we are microbiological wise on the safe side. And then afterwards, after the extraction, we go through the cooler. And behind the cooler, there's a point where we can talk about, for the first time, about dry hopping. Some people, they have the first portion or first addition of hops here, and dry hopping starts also then with fermentation. But the most common way to make dry hopping is here in between fermentation, maturation, and storage. And where the yeast is still active, you have more impact from the yeast, as I mentioned before in my last slide, referring to the biotransformation. But here's also the point where we can start with an addition of hop oils. And when we want to mimic dry hopping, so that's the right point of addition, when we replace the, let me say, the pellet addition partially, or where we can replace it completely. Next point for hop oil addition is here at filtration. If it is before filtration, if it is in between the Kisugur filter and, let me say, stabilizer or trap filter, but at least it should be before the last step of filtration and not later on. Because to have a good homogenization, to avoid problems later on and discussions, it's better to have a last filtration step here before we add the oil to our beers. So what happens in the kettle? More or less, I have a loss of the volatile fraction by evaporation. So normally none of them, or sometimes in very small concentrations, they remain in the brew. And also the monoterpene oxides and the esters normally are evaporated here at this point, but not that completely. than the non-polar fraction like myrcene. When we go to the whirlpool, here we can achieve a yield regarding the monoterpene oxides around 50 to 70%. And that also depends on the time in the whirlpool. That depends on the solubility of the pellets. It also depends on the mixture in this vessel and the time I need to chill down my wort, because I have a certain evaporation that's still in the whirlpool where we have some losses of these compounds as well. We will also find some esters, some ketones, but the non-polar volatile fraction will evaporate mostly, I think. Talking about the hopback, we found in some tests linalool yields over 80%, and we also found high concentration of the volatile fraction because there's no point of evaporation in between the whirlpool and the wort cooler. And so what the compounds who are transferred or extracted here in the hopback from the pellet material or leaf hop material, that is completely transferred into the fermenter. Coming to the fermentation, what happens there, especially when you have a hop addition at the beginning of fermentation process, you will see that we have a lot of losses again for the volatile compounds, for the nonpolar compounds with the CO2 and also by adaptation to the yeast cells. And we have seen the biotransformation that starts here. And but finally, by all these losses of volatile compounds, the beer will have more or less, let me say, late hopping-like character when we only have an addition here to fermentation. That's the real point of addition for dry hopping into maturation or into the storage tank. And here we are able to mimic dry hopping with hop oils. That is the point where the addition should be. And yes, the time of addition, the point of addition, if it is very early, late, or after the maturation, has a very important impact because the enzymatical activity of the yeast has a summit and then it goes down again, especially after maturation, and then the impact from biotransformation is not that high anymore. And that is the point where we can talk about hop oil addition to mimic late hopping character. That works very well. I will talk about the products for this later, but for dry hopping, yes, it has an impact, let me say, like dry hopping when you add hop oils on this point, but it's not the real dry hopping effect, not the real dry hopping character you find here when you do it to maturation into the maturation tank. So now let's talk about this product range that we have. We call them type Noble, Noble Plus, to create or to mimic a late hopping like character. Not talking about dry hopping. So late hopping means I have a focus on terpene alcohols, especially here on linalool. We use sources, hop oil sources from CO2 extract or from ethanol extract, and by some kind, let me say, of distillation, we produce a base oil, and by special technologies, we are able to bring out this linalool increased type Noble or the type Noble Plus. That is, let me say, one plant or one device that you can use to produce this generic hop oils. So you see there's a lot of technology behind to increase or to reduce certain hop oil fractions. So one product that we call generic type dry, that is more or less the natural composition of a hop oil, high in myrcene, low in linalool, and you find certain concentrations here of the sesquiterpenes, caryophyllene and humulene. By producing Noble, we reduce the concentrations of the terpenes. We see here myrcene is down now to 7, caryophyllene and also humulene was reduced drastically, and we increase the linalool concentrations here up to 10%. That is our specification, that linalool must be 10% of this hop oil type Noble. That doesn't mean there's nothing else inside. That also means that we are able to find geraniol, we find terpineol, and we also find some esters there. But that is the leading substance for this product. And when we go to the Noble Plus, where we are able to double linalool concentration to 20%, and also with the same step to reduce the myrcene, caryophyllene, and humulene concentration as well. And on the right side, we have the variety-specific hop oils. They are completely produced 100% from hop pellets and from one and the same variety. But coming back to the Noble, because before we go to the variety-specific ones, that is my recommendation. If somebody is looking for a late hopping like character and the application of hop oil type Noble from our house here, prior to the last step of filtration, the 60 microgram per liter, that is a good value, and that is also achievable. And you find a very mild hoppy and herbal and floral character in this kind of beers. So that is my recommendation, to come up to the 60 microgram per liter. But what we need to consider before we add the hop oil type Noble, that is our, let me say, linalool concentration that comes from the base beer, that comes from the brew house hopping. And so we have to add a certain portion of hop oil type Noble to come finally to this 60 microgram per liter. So next, the next product range that we have are the, let me say, we call them type dry. So these are hop oils to mimic dry hopping or to replace pellets in dry hopping, 100% or partially. And here we have this remaining hop oil type dry generic coming from the fractionation of the base oil from the sources ethanol and CO2 extract. And on the right side, we have extraction from pellets from certain varieties. And that is how it looks. It's, let me say, evaporation, a distillation of hop pellets with this device by steam, by heat. And then here we have a condenser, and behind the condenser, we have in this small glass cylinder, we have two liquids. That is the hop oil on the ground and the water fraction here on top. And here we can divide it and split the hop oil from the process to produce the variety-specific hop oils finally. Another option is to make it from extracts. Here with thin film evaporation, it's also possible to produce variety-specific hop oils. That is something our colleagues in the US do. And here at the end, we can say in a product form of extract is also an option to remove the hop oils and to bring these hop oils there on the market. What we all know, that is the swelling behavior of hop pellets. And what we found out is that normally by volume, they can swell up to 6 times. And swelling means I have beer losses. The more they swell, the more beer losses I have. That is by volume, but the density of hop pellets is not that high. It's in between 550 and 650 gram per liter. That means by weight, you can lose up to 11 times of the beer. And that can be very high losses, especially for these heavy dry hop beers. It can go up to 30% of the tank volume, and that is a lot of money that you waste. And that's also one reason why people now tend to go to hop oils or partially to hop oils to replace the pellet dry hopping. We once made a test at the fair in Nuremberg at the Brau, and we produced a pale ale from P90 variety Bravo, and we also produced one with hop oil from the variety Bravo, and these were added in dry hopping to the tank after fermentation. That means we had the maturation process as an impact on both of the products, pellets and hop oil from the same variety. So the addition was adjusted regarding total hop oil addition. That's correct. That is something that we found out. That's always the right way, not dose regarding linalool, just dose regarding total hop oil. So what we found out from 700 tasters in average was that in between the pale ale with the pellets and in between the pale ale with the hop oil, there was not a significant difference. So it was, we were very surprised that it was nearly looking the same. And so we thought, wow, that must be something that we can substitute pellets with hop oils from the same variety when the addition is at the same point in the process. So later on we did another test. Then we used the beer again and the base beer again, and then we did the hop oil addition from Bravo to filtration. And then we made a tasting in-house, and that was the outcome, and that was completely looking different compared to what we have seen before. So I overlay it here with the result coming from the oil addition at maturation, and you see that was a completely different beer. So that that shows again what I described before. The point of addition is very important for the impression of the hop aroma when we want to mimic or replace dry hopping with hop oils from pellets. So here we have a new variety that is not released yet. It's still an experimental one. That is the 09326 that is growing in the soil in Yakima in Washington State, US. And so that is the profile of the hop varieties that we see here. So it goes into the direction citrusy. It's not that fruity. And we have this, let me say, a sac here that is resinous, spicy, and herbal. But citrusy is very high present here with 4 points. And this variety maybe has a future because it has a relatively low alpha acid concentration. And so the impact coming from bitter compounds, especially in dry hopping, is not that much compared when you use bitter varieties. When we produce the hop oil out of this variety of the raw hops, and we dosed it to a pale ale, and that was also a result that we got from the tasters, and we were a little bit surprised because, okay, we see high fruitiness, high citrusy again. We see also some sugar-like. That was yes, we were not expecting sugar-like sweetness, and the herbal and the resinously was also reduced here when we used the variety in form of a hop oil. We did the same with the pellets in the same beer to compare with the results from the hop oil, and that was showing more or less the variety characteristics that we have seen in the slide before, where we were talking only about the hop variety and not about the hop variety in beer. But here we see that the hop variety is also reflected more or less completely in the beer, and there's a big difference in between a pellet addition with the same variety compared to a hop oil addition from the same variety, and that is something that we have to know. So if we have a beer that is traditionally produced with a certain hop composition or certain variety in dry hopping, and when you want to turn to hop oils, then you have to know that you have to first check it out how it behaves. Do I have the same effect? Is the beer the same than before? And also the point of addition has a very high impact, as we have seen. So that is one example for hop oil application that is now available here in the German area, in Bavaria. There's a producer for the first hop lemonade, and this company is using, let me say, a certain composition or special composition and recipe of hop oils. And this is a very nice drinkable lemonade with a hoppy flavor, with a hoppy character, but without any bitterness. That's something that I found here on the worldwide market. I was looking for non-beer hop oil applications, and I've found waters, I have found hard seltzers, I have found ciders, and so on in different countries, in different continents of the world. So it's also possible to use hop oils for other applications, for other beverages as well. So coming to the end and coming together to the points I presented before, we have seen the advantages of hop oils. That is, on one hand, that is a masking effect on aging compounds, and we can mimic a dry hopping and also a late hopping like character. The late hopping like character is, let me say, is very close one by one compared to the to a late hopping addition in the brew house. Dry hopping character has to be adjusted and is maybe not 100% the same by a substitution of pellets with hop oils. We have no annual variations. That means all the things that we have seen, that is the concentration of linalool that differs from crop to crop, and also the ratio linalool to alpha acids that differs a lot from crop to crop. Here we have no impact. That is 100% oil in a diluted form. We have no plant material or foreign materials. There's no bitterness inside. There's no green material inside. It's light stable. So for light stable beers, it's also possible to use these products. We have no influence from the bitterness, and we have no nitrate. If nitrate is a problem, and you have to think about reduction of nitrate because you have a very high hop addition for dry hopping, then you can also think about an application of hop oils instead, or as a partial replacement of your pellet addition. And we have no beer losses in dry hopping, as we have seen on the slide where I presented the losses that can occur when you have high pellet additions because of the swelling factor. So we have some different, let me say, dilutions or form of dilutions on the market available, and normally we make all this type dry. If it is generic or if it comes from a certain variety, we do it in ethanol and we do it in PG. So pre-dilution is always in ethanol, and the main dilution is then in PG, and that is the best practice to produce a stable product that does not turn to precipitation or to haze. It's also possible to make it 1/100 in PG, but this tends to form haze after a while. It's not that stable than the second option. It's also possible to make it 1/1000. That's for brewers who have a dosing system that is built to dose higher portions, so they don't have to change the pump equipment. And it's also possible to make it in ethanol 1/100, but then it's dangerous good on transportation regarding our national regulations here on the road in Germany. And that's also a form, and it's also possible to send it undiluted, and in the brewery you make the dilution in ethanol or in PG, depends on what you like more. For the Noble Plus, we normally make it 1/100 and or 1/1000 in PG. We have no pre-dilution in ethanol. It's very stable because of the composition. The non-polar fraction is reduced drastically, and so they do not turn into haze. And also dilution in ethanol is possible, but here we have the same problems that I mentioned before with the transportation on the road or also by aircraft. It's also a problem here in Europe. You can also make a further dilution with water. For example, 1:10 in your brewery. You buy this and you make it 1:10, and then you come to a 1/1000 dilution with the effect that you can also use other equipment for dosage that you have maybe installed in the past. So that's all for now. And I hope you like the presentation and the information I added. And now you're open to ask me whatever you like. Thank you very much.
Yeah, perfect. Thank you, Frank. Very interesting presentation about the huge possibilities how to use the hop oils and which kind of flavor they will impart. Yes, a couple of questions came in, and maybe we start from the beginning. Also with regard to your presentation. So in the beginning, you mentioned you made the groups of the aroma components, and you mentioned the sesquiterpenes are only noticeable if you have a pretty high dry hopping dosage. So in general, could you specify high dosage a little bit more, or do you maybe have some idea about thresholds of certain components? And yeah.
I don't have the real threshold in my mind, but it's for beta-carotene it's about 170. For humulene it's 300 microgram per liter, and we have to know that we have losses, and so solubility is not that very good. Same with myrcene, but as far I can reflect the results from the past, we only were able to produce a dry hop beer with reasonable concentration of these compounds below the threshold. That was when we made the New England IPAs with 3 kilogram dry hopping per hectoliter.
Okay. Then there was also a question. You mentioned that it makes sense to make the late hop addition based on the linalool content, or at least to have a look on that, as the linalool content is sometimes behaves different like the alpha acids, and sometimes the late dosage is still based on the alpha acids. The question came up with regard to the total amount of hop oils versus the specific component linalool. What is the advantage of looking to the one or the other composition in case of late hopping? What do you think?
Maybe for your special beers, you have another leading substance that you are able to detect, and that is a big problem. You need you need numbers, because to adjust your hop addition when you turn from one variety to the other, or when you turn from one crop to the other. That is the problem, and that is the reason why we are focused that much on linalool. It's not everything around linalool, but that is a leading substance, and it's like key. If you find a certain amount of linalool, it normally goes parallel to a good perceived hoppy flavor in late hopping.
Okay. So, and then we have a very special question. It's about the citrusy character, and you mentioned you showed the biotransformation effect and so on, and especially in case of a non-alcohol beer, 0.0 beer. It is probably not you don't have this effect, and the question is how to achieve a more citrusy character in this case. Is it more on the geraniol or in the linalool side? What do you think?
It's not all geraniol and citronellol. I think it's this whole terpene alcohol group, and there are also maybe some esters they behave into the same direction. So it's a more common effect from a lot of different hop aroma compounds, and it's absolutely right. If you have no biotransformation, you will miss out this effect, and that is the same when you turn from pellets into hop oils, because when we make hop oils, we are not able to distill or to transfer the precursors, and so the biotransformation is only limited to the geraniol that I have in the hop oil, and there's no geraniol pushed in from the precursor. But you're right. If you make an alcohol-free beer, yes, it's hard to have both. To have a good citrusy character, maybe you have to have a look more into the into certain varieties. Which varieties form the highest citrusy character? We have seen the 09326, for example, and if we have the impact coming from the yeast, it's always can be a problem with the formation of alcohol or increase of your alcohol level in non-alcoholic beers. And that depends on what you want to achieve. You want to stay or if you're free to go to 0.5, then you have some space to move around and to try some other technologies. But when you're limited to 0.03 to 0.00, then it's hard to get everything balanced very well.
Yeah. Okay. Then we have a question about the dosing point. So what do you think, is there any negative effect if you dose the hop oils at the very late stages of the beer production, like during filtration, or let's say even at the bright beer tank, so after the last filtration step, besides of the homogeneity which might be influenced? Do you see any impact, let's say, for example, also on foam or something?
Start with the foam. There's no impact on foam because the dosages are that small, so foam is not impacted as far as we know and as we have seen. This is a very late point of addition, and if you use this point to mimic dry hopping instead of using pellets, you will see that the beers will be overloaded a little bit with this terpenes, and especially with myrcene. And so there's no, let me say, cleaning up effect by the yeast, by CO2, by adaptation of yeast cells, and also adaptation from other true particles. They also remove a little bit of certain terpenes to bring it a little bit more smooth. That the dry hop beer is smooth, and when you have a late addition at the latest point, you have the highest utilization. That's right. You get the most of your money and of the oil. But I think the harmony of the beer must also be there. If you have a harmony that fits into into the ideas and what you want to present and bring on the market, then it's the right point of decision of dosage. But
Dosage.
don't make it behind the last filtration step. Especially when the beer is filtered, it's sensitive. It's when something happens, it's inhomogeneous. If you have precipitation that can come up, and then we are talking about other problems that could lead into gushing, and then it's a very bad case. So it's best to have something safe filtration step. If it is a trap filter, you will also achieve very high utilization when you use a trap filter before the last point or before your addition point.
Okay, so you recommend it in case of both, so from technological side, but also flavor-wise to at least have a last filtration step. Yeah. Okay, very good. You mentioned, by the way, just right now, something about the stability of the beer and haze formation and so on. So the question came also up if you use the hop oil instead of dry hopping with pellets. Do you have an idea about the colloidal stability of these beers, and how does the haze behave, and is there a huge difference?
Yes, that is. I think it's more or less logical when you have no dry hopping. You don't bring in polyphenols. I think it's a high dosage of polyphenols when you make dry hopping. And so when you have a certain balance of polyphenols and proteins in your beer, and then you add another portion of polyphenols, it starts to form hazy compounds again. And so that's the reason why these dry hop beers are often that hazy, because you start again colloids and you form troop, and then you have to know what you want to achieve in your final container, in the beer bottle or in the can. Is it a beer that is still very cloudy, or has it a certain turbidity? Can I adjust the turbidity? I think when I have a heavy dry hop load and the beer should be on a very, let me say, normal turbidity, I have to give the beer a certain period of time that it will start to stabilize a little bit again, and also to form sedimentation of these new hazy compounds. You don't have this problem when you use hop oils.
Okay. And then there's some questions which I like to put together about yield and let's say, or the other hand, losses. So what do you think about the losses during filtration, but also the losses in the beer finally. So maybe we can split the question either to the product range that are linalool based, and on the other side to the dry hop flavor categories. What do you think about that?
If you dose the oil together with Kieselguhr and bring it to a to Kieselguhr filter, you will see some losses regarding the especially regarding the mono and sesquiterpenes. That is something that we found out, but I think it's not that much when you use beer that was dry hopped with pellets, because what I think is that let me talk about myrcene, for example, that myrcene tries to find a partner to connect with in form of a microorganism like yeast or in form of a true particle, and because it's non-polar, it does not want to stay in the liquid. And when it found a partner, then it's able to be filtered out or centrifuged out of the beer, because it's not in a solution anymore. But when you make it with hop oils, I think you don't have that much time that the beer can react together with the myrcene, that you have high losses of myrcene that's comparable to the high losses of myrcene that we found by filtration of dry hop beers with pellets. So that is one thing I have in mind. And later on the shelf, we, especially for bottled beers and a little bit for beers in keg, we have no really information about beers in can, but for bottled beer especially, we see these losses of the volatiles on the shelf that started sometimes very early after the filling process, and that has a big impact on the let me say on the flavor impression that you find on these dry hop beers. And by losing these volatiles, the flavor impression is changing day by day.
Yeah. Okay. Thank you very much. Then there's also the question about the dosing equipment. Let's say which kind of flow meters you need and so on. Is there any specific equipment that you can recommend, or what do you think about this?
So I think the later you add the hop oils, that's independent of it, if it's for dry hopping or to mimic late hopping, the more specific the pump system must be, the more accurate the pump system must work. Other example, you make the hop oil addition to maturation. So you add hop oils on the transfer from the fermenter into the maturation storage tank. Later on, you have a second fermentation, you have a mixture like a natural agitation of the beer. And so it doesn't matter that much if it was a homogeneous dosage of the hop oils or not. But when you go to filtration side, I think it should be a homogeneous dosage over the flow, depending on the flow. So what you need is a flow meter, and that is connected to a pump. And a piston pump, you can adjust to information that comes from a flow meter to add more, to pump faster, or to pump with a higher hop or not.
Okay. Somebody was asking about farnesene, a typical component that is only present in certain varieties. Maybe you can shortly say something about it, how to put this into the beer if you are looking for a farnesene enriched product. So probably with a type Noble and Noble Plus it will be difficult, but maybe with a more on the variety specific side there are options. What do you think?
Also farnesene has a very high threshold, and also farnesene compared to humulene and beta-caryophyllene has a much lower concentration. That means how much hops I have to add, how much hop oil I have to add to get an impact on flavor by farnesene. And next question, has farnesene a positive impact on the beer? Is it a positive flavor compound regarding beer? I think farnesene is more or less an indicator for the so-called noble hops, and that's all.
Mm-hmm.
What do you think, Sandro?
Yeah, it's tricky. Yeah, it's true. I mean, if you're using or let's say if you try to apply a hop oil in a beer where you already used a variety that contained this component, it's probably more of importance to really mimic dry hopping finally with an hop oil.
Yeah.
But on the other hand, it's hard to find exactly this flavor finally in the beer as well. So
yeah.
but with having all the aroma substances together, you never know what comes out. So this is also something that is probably very, very specific for each beer. So we are close to 11:30 now. I would say we make 2 more questions, and if there's something left, we will pick them up by email later, if you agree. So, for example, I have one here is again regarding the dosing point. If you like to mimic the dry hopping character with hop oil, is it better to add the hop oil between fermenter and maturation tank or before fermenter? What do you think, Frank?
The more earlier you add the hop oil, the more losses will occur regarding the non-polar compounds like myrcene, like limonene, also some cariophyllene, some other compounds we maybe do not know. So that is a effect by, let me say, by the CO2 that comes up, especially when it's over the whole time of fermentation. You will smell the hop compounds in the gas that comes out of the tank, so it does not stay anymore in the beer. And when you make it later on a maturation, you still have, let me say, something like second slowly fermentation. So this cleaning effect, losses by adaptation, also when you have removed a little bit of the yeast, that is on a lower level than at the start of fermentation. So the result will be different, and the result will be more in direction to dry hopping character when you have this addition to maturation and not to start of fermentation. That's what I think.
Mm-hmm. There was also the question about different filtration systems. So between beer membrane filtration or Kieselguhr filtration, do you see there's a difference in the recovery of certain aroma components? What do you think?
That's a good question. We are still looking to find, let me say, an industrial setup to test the dry hop beers on filtration with a membrane system. That's hard to find, and yeah, it's also maybe it's not in the interest of the supplier, but we have results from Kieselguhr filtration on certain hop aroma compounds. That was also one of my presentations. So I don't know exactly how a membrane filter behaves. Yeah, to be honest.
Yeah. Okay, so maybe somebody who's listening now and has a membrane filter on site, they are interested now in checking this more detailed. So maybe this is a good starting point.
Yes, but Sandro,
okay.
you know, it's a problem.
Yes.
If you have a big brewery with a membrane filter system, they do not produce heavy dry hop beers they want to filter. So that is I think is also a problem.
That's true. Yeah. So it would be a very specific question and recipe and beer finally.
Yeah.
Okay. I hope we covered all questions. If we just missed one, we will review it and then we give you some email afterwards. Yeah, I would say we close it now as we are 5 minutes on top anyway already. Let me thank you everybody and Frank also for the very interesting topic today. You will soon receive an email including a link to review a record of today's session. And I would like to say that we have the next webinar on the next Thursday, so it's the 2nd of July. It will be held by Willy Mitter, and he will talk about a very interesting and new device to reduce beer losses during dry hopping, if dry hopping is done with pellets. So we switch again from the hop oils to the conventional products. Yeah, thank you again, Frank, and everybody who joined us today. And we hope to see you soon again. Stay healthy and all the best from our side. Bye-bye.